The moment of inertia of a body about a given axis is 1.2 kilogram meter square. So the given values, moment of inertia I is equal to 1.2 kilogram meter square. Initially the body is at rest. So initial angular velocity is at rest. So you can say the initial angular velocity is 0. In order to produce rotational kinetic energy is 1500 joules. An angular acceleration of 25 radian per second square. Angular acceleration 25 radian per second square. Be applied about that axis for a duration of, so the duration we have to find. So to solve this problem, we will first find the final angular velocity, that is omega final. We have to first find it because we have the initial angular velocity. If there is an angular acceleration, acceleration is final angular velocity minus initial over time. So we need to find angular velocities, very important. To find this final omega f, we need the kinetic energy rotational formula. It is half I omega final square, because omega initial square will be 0, so the total term will be 0. Okay, so we need to find the final omega square. So kinetic energy rotational is 1500, and here is half times I value is 1.2 times omega final square. You can take this to the other side. 2 times 1500, 1.2 to the denominator, and put the square root, because to remove the square we take the square root both sides. If you solve, the omega final would be 50 radian per second. Now we found omega final square. Now what are we going to find? The time, duration we have to find. So we know the formula, the v is equal to u plus at, the linear equation, same. V is final velocity, so final angular velocity. This is initial angular velocity plus acceleration, angular acceleration, and time is t. So this value is 0, and this value 50 is equal to alpha 25 times t. So time is equal to 50 over 25. So time is equal to 2 seconds is the answer.